Hello everyone, my name is Kevin Gordillo. I'm from Colombia, and today I want to talk to you about visualizing security principles to access resource based on linked open data with a case of study in DBpedia. This paper was written by Paulo Alonso Gaona, Kevin Gordillo, Carlos Montenegro, and Adriana Gomez. So, the program. First, a little introduction to important concepts to understand the main idea of this paper. Second, the research problem. Third, the objectives. Fourth, the proposal model. Fifth, case of study DBpedia with two examples. Sixth, the results. And finally, the conclusions. First, introduction. What is linking data? What is Web of Trust? Linking data is a way to share data and interconnect it to make it more useful. For example, if I'm looking for a sickness like leukemia into a linked dataset, I could see a lot of related information. For example, medicines, components of that medicines, research, medical records, and of course, there are more topics on linking data, including multimedia, like music, video, and images. But how can we be sure that sites and information that we are consuming as linking data is trustworthy? I mean, who is the real author? Can I use this information without restriction? We use the term Web of Trust to refer to a set of pages and dataset where we can be sure about the origin of the information and the way to access it. In this order of ideas, the research problem arises. How can we determine the authenticity of dataset in linked open data? Because in LOT, all the datasets are public and everyone can share anything. So, our objectives research were mainly to first determine the trust level that could have a dataset based on Web of Trust principles, the SPARQL endpoint, and the license. And second, design and develop a navigational interface to visualize datasets and their trust level. Proposed model. How can we determine the trust level of a dataset? We extracted around 1050 metadata of datasets from datahub.io, and we discovered that only 6026 datasets were following in a correctly way the four rules for data vinculation mentioned by Tim Berners-Lee. Then we created a Mandami fuzzy logic system for help us to process the metadata and inference the trust level of a dataset. We based on four main files from the metadata to create the inference rules. Those fields were the author, the maintainer content, the license URL, and the SPARQL state. With those fields, we have an approximate way to establish what could be the trust level of a dataset respect to other. Application developed. Visualization of a dataset and level of trust using a web application. The application model was really simple. First, we have the Data Hub repository and the API CCAN for access the metadata of dataset located there. Then we have the interpreter of response from CCAN. When we make a petition, we use JSON to parse JSON files. After that, we saved the data on a database using PostgreSQL. And finally, for the visualization relations and datasets, we have used a Gephi engine and Sigma.js with a template provided by the Stanford University for data visualization. We define three main colors for the arc relationships in the graph. Red for not very trusty dataset, green for a medium level of trust, and blue for a good trust level. The graph with the 626 dataset is as following. Here we can see that the majority of relationships are in the red color. It means that almost all datasets have problems with trust level about the information that they are sharing on with other websites or datasets. Now, let's see the DBpedia study case. Currently, DBpedia has income relationships in DataHub.io with around 166 datasets, mutual relationships with 10 datasets, and also it has more than a billion of triples. In this first example, we can see the relationship between the Freebase dataset and the DBpedia dataset. The outgoing arc from Freebase to DBpedia is in blue because it's accessing a trusted dataset. It means DBpedia. But the incoming arc is in red because Freebase is not a trusted dataset. So, according to our model, DBpedia is referencing in this case to a dataset where we cannot determine the origin of the information and we cannot access or consult the data who DBpedia is referencing to. On the other hand, we have the relationship between DBpedia and the New York Times. Both are in blue color. This means that the outgoing arc from New York Times to DBpedia is accessing a trusted dataset. The same goes with DBpedia to the New York Times. It's because both datasets have license, a SparkQL endpoint active, and a maintainer, and one or more authors. Results. We have discovered that the majority of datasets are using a not certificate license. For example, these only put the value other or simple open value in their metadata. It could be a really huge problem in the future related with copyrights. Then, the most used license for sharing content in linked open data is the Creative Commons attribution. Of course, there are more licenses. The majority are from Open Declaration and governmental license. Of the 126 dataset, it was found that the 43%, around 267 dataset, obtained a score below 0.48 in the diffuse inference system. That is to say that they have a low confidence level and it's difficult to establish contact with the creator of the resource and its authenticity. The 12%, around 76 datasets, have a medium level of trust. That means that you can contact the creator or the maintainer of the dataset or have a license to use. However, it doesn't present all the required fields. That is to say that mostly they present license or author, but not both at the same time. Finally, in the remaining 45%, around 283 datasets, are the datasets with which you can have a good trust level. Since they have a license of use or creation, an author or contact of the maintainer, and a SparkQL point active. Of course, talking only about the data in datahub.io. Then we have the conclusions. First, the rules applied based on Web of Trust principles is an example of representation that could improve the presence of linked open data in repositories. However, it's necessary to carry out studies based on a great range of datasets in other repositories with the purpose of determining stronger results as a future work. And second, we must consider that the Mandami system in fuzzy logic are called expert systems. That name because the results depends on the people who are making the inference rules, in part with a subjective opinion. Somehow, this can influence in the level of trust defined. For that reason, it's necessary to define another model or tool that supports the present model. Thank you to the Universidad Distrital and the GIRA Research Group for making possible the realization of this research, and to the Third International Congress on Economics, Social and Information Management Congress for the possibility to share our results to the world. I really appreciate your time for listening to me, and I hope you have enjoyed the presentation. If you have some questions, you can email me at the address on the screen. And thank you again, and until the next time.